first off, thank you all for coming out here to Cincinnati and being here for what we're calling our KARNO Generator Showcase event. So I think many people have seen the KARNO generator, whether it be on video or in PowerPoint presentation, but we want to take today as an opportunity to bring a lot of folks in and actually get a chance to see this all happening live. So before kicking off, just want to start with a safety overview. So first things first is this is a live facility. We have additive manufacturing happening as we speak. We're going to be running the KARNO generator today, so please be cautious as you're going around the facility. Watch out for any potential trip hazards, or if the team is advising that there is high voltage in a certain area, please listen to them. This is just a quick disclaimer from a legal standpoint about being a publicly traded company, so we'll keep moving through that. The agenda for today. So we're going to kick off just talking a little bit about this facility. We moved into this place about 6 to 12 months ago, and we'll cover some of the highlights of it. I'll do a quick tech overview. I'm sure many of you are already familiar with it, but just a refresher. And then I'll talk a little bit about the target markets that we're going after. Then from there, what we've got scheduled is we're going to break into groups, and we have 4 different areas that I'll cover here in a minute where you'll be able to experience both additive, the dyno, combustion lab, as well as a deep dive overview of how the tech actually works. And then at the end, we expect this to be about a 2-hour event. We'll come back here and just cover a little bit about the roadmap and what we have planned for 2024 and 2025. So these are the 4 stations I was mentioning. So just to cover them again. So the first one is the dyno, which is over here. You can actually see the 4-shaft KARNO generator in there. Then behind all of you, you have the additive printing. So all those machines, both the smaller ones on the left side as well as the larger ones on the right, are different generations of additive printing. Then upstairs, we actually have our emissions lab where we're able to test different fuels. We're able to see how the reaction to the fuel actually happens, and you'll get a chance to actually see, or kind of not see, flameless oxidation. So you'll see that we're bringing fuel in. You actually can't see a flame, but yet all the metal around it is glowing because it's producing that much heat. And then lastly, in the room to my left, to your right, we have a station where we're going to showcase how it works. We have additive parts on display, some cutaways of those parts to really give an in-depth view on what is this technology, right? Because it's very different than standard engines or generators out there. And then just a quick couple of guidelines. So one is, please do take photography and videos while you're here. We just ask that please just keep it to those 4 areas that we have on display. There are engineers at work designing proprietary parts, so we ask to just stay to those 4 areas if you are going to take photos. And then we are going to be doing some videography as well, so if you would prefer to not be in any videos or in any photos, please just let your tour guide know. And then the last thing is just stay with your group. When we break into those 4 different groups, we'll be moving everyone around the facility, so please stay with your tour guide. All right, so to dive into things, facility overview. So we now have 2 locations. We have Austin, Texas as our headquarters. We have our 150,000 square foot facility there. Conventionally, or used to be, that we were producing the powertrain technology there. We're now shifting that to this is going to become our manufacturing location for the KARNO technology. So what we envision in the years ahead is going wall to wall through that facility, lining it with these additive 3D printers to be able to produce the KARNO generator. And then we have the Cincinnati facility that we're standing in today, which this is really a R&D focused facility. Now, the reason we're in 2 locations, and many of you are probably aware of this technology originated out of GE's aviation group, which is located about 20 minutes away from this facility. So we used to be in GE's facility, and then we recently moved into this location where we're going to start our low volume production out of here, as well as keep the engineering team up here. So a couple of fun facts about this facility is one is it was designed to be an extremely energy efficient building. So it matches with the vision and the goals we're going after. So as you probably saw when you were driving in, there's a wind turbine, there's solar panels on the facility. We have geothermal heating in the back of the facility here, as an intelligent ventilation system, as well as all the rainwater is captured both in a reservoir up front as well as the pond that many of you probably saw driving in. And then lastly, we have EV chargers. So if you did drive an EV, hopefully you plugged in and are getting charged up while you're here. But what's exciting about this facility is we've also designed it where we can easily incorporate in the KARNO generator. So while we're actually running the genset to my right, we're actually able to pump that electricity back into the facility to power it, or if we're producing more than the facility itself is consuming, we actually have the ability to push that power back into the grid as well. So transitioning now, just a quick overview on the KARNO generator. So many of you are probably aware of this, but what we're hearing continuously from customers, many of you, is that you want sustainable, reliable, and easy to adopt solutions. If you think about generators in the past, they've usually been kind of viewed as, hey, I'm going to put this outside my facility and only use it for emergency backup power generation. We're really looking to change the model to where now the generator can actually be your prime power source and you use the grid more as your backup energy supply. But in order to actually get people to buy into that vision, these are the three things that, that customers want to see out of a generator technology. So that's where we've come out with the KARNO 200 kilowatt system. Many of you have seen it kind of presented as a 4-shaft system like in the generator here. What you can see on the screen here is actually what the deployable units are going to look like. So it's about a 8-foot by 8-foot by a few feet wide box that encompasses the 4-shaft system. And then this also has all of the radiator, blowers, everything that's needed to operate the genset is inside this box as well. In addition to that, it's already designed to be able to offer combined heat and power. So that means that we can use some of that excess heat that we have from the genset to actually provide that to a facility, to provide heat or to provide hot water. So these initial units that we'll be shipping will already have that capability incorporated in them. And then to do just the quick overview on the tech, hopefully you all came with a lot of questions to actually ask the team that you're going to be meeting with today, but take everything you know about how internal combustion engines work and put that to the side for today. That's one of the things that we find is kind of the most challenging to wrap your head around is you see this linear shaft system with pistons and you expect, oh, well, you bring the fuel in, you explode it, and that pushes the piston one way. That's not the way this system actually works. So it does have that piston setup, but from the left to the right-hand side of that piston array, it's actually a completely hermetically sealed system. And it's pressurized with helium, so none of your fuel, none of your outside air actually enters that area. The only purpose for the fuel is actually to produce heat. So we have this continuous burn or flameless oxidation of the fuel that produces heat. And then our only goal is we transfer that heat into that linear generator system that produces pressure changes, and that's what actually moves that shaft going back and forth. So because of this architecture, it brings forward a lot of inherent benefits I'll cover in a second. But this type of technology isn't new. It's often been referred to as Stirling engine technology. It's been around for over a century. But what we're doing that's different than what NASA did in the 80s is we've been able to leverage additive manufacturing to make some of the key components. So our kind of North Star, what we need to achieve is really, really good heat exchange. And that allows us, and what additive does is it allows us to design components that could never have been manufactured in conventional practices, and that allows us to unlock really strong heat efficiency benefits, and that's what allows us to get the efficiency and performance out of the KARNO. So what we're targeting is about a 50% electrical efficiency. So that means if you bring a drop of fuel in, 50% of that will be used towards making electricity, and then the other roughly 50% is going to be excess heat that could be used. So as I was talking about combined heat and power, now if we're able to provide 200 kilowatts of electricity, you can provide just a little shy of 200 kilowatts of heat as well. And then because of this architecture, the Stirling engine design, these are the inherent benefits that come from the product. So one is the fuel flexibility. Since the only purpose for the fuel from our end is to produce heat, as long as you can react that fuel, we can use it, right, for the most part. So whether that's natural gas or propane or hydrogen or even conventional fuels like liquid fuels, you'll actually see a liquid test bench upstairs when you're going on a tour. We're able to use that as our heat source. One of the other proprietary things is the way we react the fuel allows us to achieve very low emissions. So very different than an internal combustion engine where you're kind of rapidly exploding fuels one after the other. What we're doing is this continuous process of flameless oxidation reacting the fuel, which allows us to really drive down the NOx levels, the CO levels, to a point where we're north of 95% lower than a conventional internal combustion engine when running on comparable fuels. And then high efficiency, so our only output of this generator is electricity, right? So if you think about a normal generator, they produce a rotating power, right, that you can use in your car. What we're doing is the only output is electricity because in the middle of the genset is this linear electric motor, magnets and coils moving back and forth, and that's what's producing the power. And then minimal maintenance. So you'll hear today that the system's design, no oils, no lubricants. It actually rides on air bearings. So it allows us to see much longer intervals between maintenance than conventional gensets. Smaller footprint. This system here, compared to other comparable generators that would produce similar power levels, is about half to a third the size, or even compared to some newer age technologies, we're like 1/10 the size compared to what they're producing. So a small footprint gives a facility a lot of flexibility if you're trying to deploy these. And then lastly, low noise, which we'll showcase today. I like to describe it as it's more comparable to like an air conditioning unit sitting outside of a facility as opposed to a large engine. So last thing I want to cover before we actually go into all the exciting things of showcasing the technology is just the markets we're going after. So there's really 4 buckets that we're focusing on. The first is EV charging, waste gas, prime power, and then mobility. So if you take those 4 and you kind of break them down into subsections, these are the markets that we're anticipating first deploying the KARNO generator into. So EV charging, we see 2 opportunities. One is just stationary. It'd be like taking those chargers we have out front, having a KARNO generator next to them, and providing that power. And then the second is mobile EV charging, where maybe you don't own the facility, or maybe you have vehicles that are moving from one location to a next, and you could have an actual mobile mounted KARNO generator with a charging pedestal as well. Waste gas, so being able to capture methane coming off of landfills or what would have normally been flare gas out of oil and gas sites or field gas. Since we have that property of being able to be fuel agnostic, we can actually take dirty or unpurified fuel, run that through the KARNO, and produce electricity. Prime power, which is the one that probably most of you think of commercial buildings like the one we're in, industrial applications, or even where we're seeing a lot of momentum is in microgrids and especially data centers. I'm sure all of you are aware with the AI boom that's happening, the need for more and more data centers is skyrocketing, and that's putting a toll on the grid. And often data center builders are finding that they just can't get the electricity needed from their utility provider. And then the last application that we're focusing on right now is the marine application. So that would actually be being a power source on a vessel to power the boat. So there's a lot more opportunities than the ones that are just highlighted on the slide here, but these are the areas where we're going to be targeting for our initial adoption. I'm excited to say that in every one of these buckets, we're in deep discussions with customers, prospective customers, and we're talking with them about being part of the early deployment of the KARNO generator. And to that, over half of them, we've actually already secured initial customers in, whether through LOIs or through agreements with those organizations. So you can see some of them we're at a point where we signed agreements. We're not ready to publicly announce them yet. Those are the blue checkbox marks up there. And then for mobile EV charging, we're working with GTL or GT Leasing. And then in the oil and gas space, working with Detmar Logistics as well. So hopefully that gives you a little bit of a frame of kind of where this technology is going, where we see it applicable. With that, that's all I had to cover on the front end here. So what we want to do now is actually break into groups and actually let you go kind of experience all this firsthand. So we've got 4 different groups. If you look on your badge, you can see what group number you are. So if you're part of group 1, we ask that you just head over to the KARNO generator here, the dyno. Group 2 is going to go back to the additive machines. Group 3, why don't we have group 3 actually meet up here to my left, and then group 4, you're going to meet just in the hallway there. So we can go ahead and disperse, and we'll come back here in a little over an hour. Thanks, everyone. Without additive, we can't possibly make the various components that go into this generator. We wouldn't be able to see the efficiency, the reliability of the system. So additive is truly that unlock. Now, one of the questions we often get is like, well, is additive really up for the task? Can you use additive in volume manufacturing? And the answer is yes. Many people are unaware, but most aircraft engines are actually made through additive manufacturing, many of the components in them. I think the stat is, if you flew here, there's a 70% chance that someone on our team actually worked on the engine on your plane. So based on the team you interacted with today, it will determine whether you want to drive home or fly home, but hopefully you're flying. So no, it's really innovative technology. Now, what we see as the opportunity is using it as the unlock for power generation, and being able to scale volume manufacturing will require more and more additive machines. So the brief overview on this is you kind of see 3 different generations of machines. If you look behind you, there's the smaller machines on the left side, called the M2s. Then we have X-line machines, which are on the right side. That was the generation after M2s. And then on the screen here are M-lines, which is even that next generation of additive. Actually, in the floor space area there where the crane is, we've got the floor marked where 2 of these M-line machines are going to be going here in the next couple of months. And so we're excited to jump into that next phase to even be able to further increase the speed and throughput of making these generators. Now, the great thing for where we are today is even with the technology sitting in this room, we're able to make an economic solution to be able to provide power to those different market opportunities that I mentioned before. And then as the speed of additive continues to get faster and faster, as laser power increases, as you put more lasers in these machines, it will allow us to even go after more market opportunities. So we're on the cutting edge, not on the bleeding edge in terms of additive manufacturing. And we see that as a great way to be able to scale, because as you saw today, there's no waste with additive, right? You print the part, you then can take that powder, that material, and reuse it, and then make more parts out of it. So the other nice thing is that as you want to scale your volume manufacturing, you just add more and more machines. It's very different than a conventional engine plant where you have to invest $500 million just to make engine number 1. We're making the generators you saw today through these machines that are sitting here, and we can just add more of those same machines to scale manufacturing. So as I mentioned before, what we envision out of Austin, our facility down there, is we just scale more and more additive machines to grow volume. Now, I'm excited to share that we do have enough machines for all of our 24 capacity, and we even have the machines on order already to produce most of what we plan on producing in 2025. So you'll see the machines here. We have these M-line machines coming, and then we actually have procured more machines to at least double, if not more than double, our printing capacity that we have here in Austin. So that's a little overview on additive. As I mentioned, we really see that as the unlock that enabled us to create this Carno technology. That brings us to what are we focusing on now, and what are we planning on in 2025? So earlier this year, we announced we've started printing beta components. So the generator that's running right now is an alpha version. The room next door was an alpha version. The next iteration of it is called beta. The look and feel of it is very similar, but there's been improvements on how do you manufacture, reliability, and even the power density. So it's a very similar size to what you saw in the genset, but beta will be capable of up to 200 kilowatts of power output. Through this year, we'll be verifying that system, making sure it's ready for field deployments. And then as we target the end of this year, later in the year, is when we'll actually get the systems out, deployed in the field in customers' hands. And then as we look at 2025, it's really about starting to scale, starting to bring the technology into to more markets as well. And what we've shared publicly is the target this year, the main thing is get them into customers' hands, and then next year is to scale into the low double-digit millions of revenue by shipping these systems. So that's what we have in store. It's a lot to do in 2 years, but we've got a great team, as you guys saw, working on this day in and day out to bring this to market. On a closing note, what we wanted to leave you guys with is you saw the generator running, but we were kind of constantly turning the genset on and off throughout the day so that different tours could see it. And we also didn't want to start heating it up too much, because then you wouldn't be able to get close to it. What we're doing now is the team's actually running the genset as we speak. It's been running this whole time, and we're letting it build up that heat. So as you're departing today, feel free to go check it out again. You can see that this is a heat generator, right? So some of the components actually will be glowing orange because they're building up that much heat inside. For this part of it, you do have to keep the doors closed. Obviously, it's an extremely hot system inside there, but we wanted you to actually get to see what it's like operating, pushing power back to provide power to this facility. So I don't know the exact power output right now, but chances are our lights, parts of the facility are actually being powered off of the KARNO generator right now. So that concludes what we had kind of pre-planned. All of you are more than welcome to stick around. You met different team members today. Ask them further questions. The only thing we ask is if you do want to go see something again, please go with one of our team members, right? So otherwise, feel free to stay in this area, check out the generator. And then on a closing note, we also brought some swag for all of you. And Andres, if I can just, so you can actually see we have these very neat Sterling generators that sit on top of a coffee mug. You may have seen when you got here that that was running, sitting there spinning. It's still chugging along. So that's basically the way that the KARNO generator works. This just is taking the heat from the coffee mug and using that to actually spin that wheel. So feel free to grab some swag as you're heading out, and hopefully all of you enjoyed the visit here. We truly appreciate you coming out and look forward to continuing to work with all of you. Thank you.